Hello, everyone. I'm Ujjwal speaking. So I'm gonna today talk about. I hope you guys didn't. I'm an on call, so I just got in a lot. So hopefully the next one responds to this, and I'm not in trouble. I've got my colleagues there, so hopefully they're gonna stand up for me. So I'm gonna talk about effect. So effect is to TypeScript what TypeScript does to JavaScript. So it sort of takes your type safety in TypeScript to the next level. So let's start with introduction. So I'm Ujjwal. I'm currently working on as a senior software engineer at Ubank. By birth, I'm Nepalese, the land of Mount Everest. I'm linked the LinkedIn in here. I've QR code to the slides at the end. So there's just two little requirements for this category theory and monads. I'm joking. I think I saw a couple of people leaving there. So no. Yeah, so if you know TypeScript, if you know the generic feature in TypeScript, promises and async await, and if you know generator, function, and yield, that would be great as well. Last minute, I decided to add one slide for generator function as a refresher because effect uses generator a lot. So before I start effect, I'm going to do one slide on generator function. So generator function is a function that's declared like a star parameter. It's a little bit different than normal function. In a normal function, you have one return value. In a generator function, you can have multiple return values. And the way you do it is using the yield syntax. So I've got a little program running in there, which yields 4 different values. So in the first one, you get 1 and then 2. You can also delegate it. When you do yield star, you can delegate it to the other function. So the way it's different is like it sort of flicks back and forth between the calling function and the actual function. So sort of flicking back, and so it's a little bit different. Effect uses this a lot. So that's a little teaser. So let's start our actual thing. So maybe the problem space, right? So what's really the problem with JavaScript and TypeScript? TypeScript really elevated the way we do programming, but the problem is like the errors are still not strictly tried, right? So imagine you got any function or you're using an SDK or something. S3 is a bad example. You probably wouldn't have that, but say whatever function you use, there's like a new error in there. That's actually breaking change, right? If you add an error somewhere in an application and you don't necessarily catch it, handle it, retry it, or whatever, your program is probably going to crash, right? And what you end up doing is like you might think you're just changing that one little function. Some of the team might be calling your functions from somewhere, and you're getting an alert in the middle of the night because someone added an exception, you added an exception, and you didn't know about it. Your test coverage didn't cover it. So the way effect solves this problem it does things a little bit different to promise. So promise only has one generic parameter success. So the resolved value. So if your result value is say an integer number, then that would be your success generic parameter. But there's nothing for error. It could be an exception type, or it could just be string or whatever. But with effect, you capture the success and error. There's also this little thing called context, but I'm gonna get to that in the later. Let's just focus on the error for now. So the way you initialize an effect is similar. The success part, at least, is very similar to promise. Kind of like how you do promise to resolve. You get success. You can see the number. Both of them have the number in there as a generic parameter. Creation effect, the typical way is also quite similar. So you've got a promise, you initialize it, and you either resolve and reject. In the case of effect, I'm gonna talk about the syntax in a little bit detail, but there's a success value and there's an error value. So if you look at the bottom, randomly I've written a value called 2. That's a number return type. So you see similar to the above one. But the extra thing in there is I've thrown an error called custom error. Now that's tracked as well. That's the game changer that effect offers. It's similar thing to the last one, but just to make sure how effects similar to an async function. So async, and then at the bottom you can see effect.gen and function star. So that's the generator function. And then similar to how you do await, you can have actually yield star on it. So that's the generator thing. So other than that, you look at it, it's pretty much similar in terms of syntax line by line. It's not very different. If no one knows if you're doing effect and other people in your team don't know effect or something, all you have to do is this one slide, async. Effect.zen is like async, and then yield is like await, and that's pretty much 50% of your effect. But the game changer here is we've thrown a custom error in here, where you could be throwing 5 errors in there. That would be tracked in the effect type. And the way you access the effect is like the old-fashioned way is like how you can do promise.dan. You have to do effect.map, and you get the value. So it's not very different as all. And the new way, async await way, is kind of how you do await promise. You have to do yield star effect, and you get the raw value, the value that effect wraps, similar to the value that promise wraps. So now let's actually start to create an error, right? So the way you create an error is they've got a little syntax that's a little bit different. So there are the tagged error, and you declare what the error is. I've created this little function called random number, similar to the last one, that randomly returns a number or throws an error. But the number is the first one success, and the failed to generate error is the second one. That's the error one. And the way you handle it, the first thing is like, now if I try to use that function, random number, instead of doing a await, I do a yield. And now I have access to the value similar to await, so not very different. The way where effect makes it type safe is that you've got when you run this helper called effect.into error type, and I specify never, that means that the TypeScript is going to complain. So anywhere in your program, you've got a failed effect, and anywhere in your application at the top level or wherever you haven't handled it and you're trying to run the program, your program's not gonna compile. It's very different than the way we usually do things. Usually you would need a bunch of test coverage, whether that's unit test or end-to-end test. Unit test is probably not gonna cut it because you're only testing one function. And you might need end-to-end testing. Worst case, you might need very slow playwright testing. And even then, you might not be able to catch it. TypeScript gives you feedback on the IDE. If you don't handle an error, it's just not going to compile. So you can also, so in the previous one, So the way you catch the error is similar to try catch, but what you do is .pipe, and then you do effect.catch tag, and you specify the error. So if you want to catch one error, then you can do whatever you want. You can log, you can retry, you can have a fallback value, and that becomes your new effect, similar to promise.catch. But here is .pipe and then effect.catch. There's also other ways of catching effect error types like catch all. If you want to catch everything and handle it somehow there. But so you can also do it at the top. So instead of doing it at the function where you're throwing error, you can also do it at the top of your program. Or if you're building an API, it could be at a controller, for example, if you're throwing errors somewhere in your services. So now because I've caught it, I should be able to run the program, and effect's gonna figure out that I've handled all the errors. So let's look at a very basic program. So I've got like 3 tasks, which are essentially effects, kind of like functions, right? So the first 2 have voids. They don't really do anything. I mean, they do something, they don't return anything. And then the third one is a number. And then the way you call those 3, similar to promises, is that you can do yield star. So what I've done is like I've decided to run effect1 and effect2 in parallel, similar to promise.all. You can do an effect.all. And after that, I've done, and then I've called task 3, and then I've console log. So it's not very different from async await at all. Effect.gen function start would be a saying. Yield effect.all would be promise.all, and then yield would be await. So it's not really very different. So that's how the error tracking problem gets solved. So anywhere in your application, whether that's a domain or service or wherever, somewhere down the line, if an error is thrown, it somewhere needs to be tracked. If it's tracked, TypeScript is going to let you go. If it's not caught somewhere, then FX is going to catch it with TypeScript, and then your program's not going to compile. So that's your compile time safety of your error types. So that's just the error one, right? Let's look at the third parameter. If you guys remember, there's like a third parameter in there. The second parameter is the error, and the third parameter is the error. So what's the third parameter? So the problem is like, this is like a common problem in software, is like you deploy stops, and then you've got memory leaks, or you've got database connections that you forgot to close, or you've got transaction, or you've got database locks that you forgot to release. And then things just go up, and you just have to recycle your database servers or your application servers every week or so. Effect can help you with that as well. So let's just take this very simple example where we've got this database connection class. It has a create method to initialize the connection. It has a select. I'm not really doing anything. I'm just returning a successful value empty array, and then you've got a disconnect, right? The way they help you track memory is that they've got this helper called acquire release. So acquire is how you create the resource, or how you acquire the resource. That's the first parameter. I've just created the connection object. And the second is how you release the resource. And the way you use it is that you just yield star. It's not very different. And then now you can do whatever you want to connection. But then the things like, if you want to run the program using effect.run fork, effect's going to be like, hey, it didn't call disconnect. That's the missing part. And how do you disconnect? So effect, because it was a special construct in effect called a scoped effect, you need to wrap this effectful program in effect.scope. Now you can do effect.run fork. So anywhere in your application, anywhere down the line, if you've created a scoped effect, and then you didn't wrap it in effect.scope, TypeScript is going to complain, hey, you have this issue. Basically, if you look at this, so the third parameter is scope. It says scope is not assignable to never, so it must be never, right? When I do effect.scope, that scope becomes never. I know it's a little bit different to how we typically do things, but then you basically wrap effect.scope. It will basically connect that disconnect method that I declared earlier, because I'm declaring the creation of resource and the releasing of resource on the same way. When I do effect.scope, effect can essentially, so not just when it succeeds, also when it errors out. So effect sort of forces you to ensure that you release your database connections, you committed your transactions, or you roll back, you've closed your file connections or any other socket connection. Sort of forces you by making it by tracking it on type level, basically. So that's the first thing, right? The other thing effect helps you is also it helps you track dependencies in a type level. And the way it's different than usual is like, usually you have some sort of an interface and you have an implementation, and you link that interface to an implementation somewhere in your application. So anyone can expect an interface in a constructor. And how do you test, right? You have to either run the program manually, or wherever you have to deploy it to a staging server, or you need to write a bunch of automated tests. And unit tests is probably not going to cover it. You probably need some sort of integration test or something, because probably testing your application in the whole. So effect can actually help you with that as well. So let's play with this very simple example. I've created this class. It actually looks like a class, but it's actually an interface, because I have this method called query. It's just declared as a type that accepts in SQL as a string, and it returns an effect. Basically returns an array of objects, basically. And if I want to use that, So similar to how you expect in a constructor, you do yield star and you get the actual database connection. And then now you can run your queries in there. The place where effect comes in, because we haven't provided the implementation to it. Effect can track it. Hey, nowhere in your program you provided an implementation. Effect is going to be like, hey, the database connection isn't assignable to type never, same meaning that I don't know what DB connection is. I can't help you there, right? And then the way I configure it, meaning how I link the interface to the implementation, is that I use these little helpers called layer, that where I say database connection, and then I specify the implementation. Here I'm doing nothing really. I'm just like console logging the SQL. And I'm just like, let's just say we're actually calling Postgres, right? Now, when I run the program with the provided implementation, now it's going to work. Whereas in the previous one, when I do effect.run fork, it wouldn't run because it wouldn't be able to resolve the interface. So very different way how we're able to track misconfigured dependencies on a type level. So it can happen anywhere in an application. You just need to be able to, at the top level somewhere, you need to be able to specify implementation. You can also easily swap it. I guess that's just dependency injection. When you want to test it, you can just swap the interface to a test implementation. But I guess that's pretty normal. So I'm almost at the end. There's a couple of little things left. So composability, if you've done, I don't know, any functional programming, maybe Monad, and even if you haven't done that, I'm kidding, I don't know Monad as well. If you've just done Lodash or something, you might have used some helpers like retries and exponential backups and things like that. The reason why they're like really great abstractions is like they let you focus on your application logic, and you can just use their little helpers. Effect offers those as well. So, but then it's probably like orders of magnitude more helpful. But I'm biased, so take my word with a pinch of salt. But basically, I've created this help function which fetches something from an API endpoint, but also has a built-in exponential backoff and retry. It also has built-in observability. I'm going to talk about that a little bit later on. But then now when I call this function, say I'm declaring 4 URLs, and then I'm doing for each through the URL, and I'm calling that function. Because it's 4 URLs, I can specify a concurrency primitive. So effect also provides a really easy way to call effects with any sort of a complex concurrency primitive. This is like a very, very basic, just a tip of the iceberg. We can do some really complex concurrent stops with effects. Now you might be convinced that effects a thing to try at least, or you might be like, the problem is like, yeah, you are convinced. How do you convince the rest of your team, or how do you convince other teams to do it? You might have some luck to convincing your team to try an effect in your services that you maintain. Effect has a really good interoperability with promise and synchronous stops as well. I'm gonna just do the promise for this one. So basically, say you've got like 2 errors. You've got a code that uses fetch, so you get promise. Effect provides a way to map the promise to an effect. So they call it try promise. On the try, you actually call the promise code. On the catch, because the thing is like promise doesn't have concept of error. Now we need to manually map those. You need to catch it, and you need to manually map those errors, which could be any or unknown, to the actual one. So I just write the code saying if error is whatever, then this is the error one. And then now your to-do function, like the old one's just promise response. This one's actually response, but you've also got 2 errors in there: to-do not found error and failed to fetch error, just because we have returned those errors in there. And it also works the other way around as well. Say you've got services and effect. You're exposing things to other teams that don't believe in effect yet. You can actually convert the effect to a promise. obviously you lose the error. So you don't really, there's no code in there. All you have to do is run promise. You provide an effect. In the previous one, we had to manually map the errors to get to get the type mapping, but here you're just losing it, so you don't have to do anything. There's so many things I've tossed on. There's also a feature called interruptibility. So you might have forgotten to add a handler for process dot on sig and sig term. It's interruptibility native for each effect. So when you close the program, it makes sure that it runs all the finalizers, so cleanup functions. It's automatically tracked natively. It also has a native observability. I did touch on it a little bit in one of the previous thing with effect.withSpan. So at the bottom, I did whatever I've done, and at the end, I said effect.withSpan. So I'm just tagging that effect as a span. So you could be like effect calling an effect, calling an effect, and everything can be tagged as a span. And the trace, which is a tree of span, can be integrated to any vendors as long as they support OpenTelemetry. So you can export it to, I tried to do it to Grafana. It was just like, I just did Docker start, and I added like 2 or 3 lines of code. And then my application was all traced. So observability is built in by default in effects. They also have an effect native schema. So it's similar to Zord, but their APIs are effect instead of promise. And the errors are type tracked as well. They've got a vast ecosystem of libraries. They've got integration with ORMs. They have AI SDKs. Yeah, they have integration with lots of libraries. All they do most of the times is convert that promise to an effect, and your errors are tracked. I think from my memory, they've got like 20, 30 packages at least. And there's like so much things in there. I've been tossed on streaming. Yeah, there's so much things in there, but that's just a little tip of the iceberg of what FX supports. And that's it. Thanks, everyone. If you've got questions, I don't know whether we have time for questions or not. Okay. I've also added the QR code to the slides, and I've also added this really cool way to learn effects using some interactive web page. So yeah.
All righty, yeah, let's do some questions.
Yeah, that was amazing. Ujjwal, thanks for that. It was brilliant.
Hey, so I noticed in your examples, you were just using ordinary generator functions, but you were doing things like connecting to databases and making queries. Why weren't you using async generators, and what effect does it have if you use just a regular synchronous generator in that case?
Good question. Generators are very interesting. They're like very powerful because generators, you can switch between the calling function and caller function. Even the normal generator function provide async functionality. So the effect actually does synchronous as well as asynchronous. In a normal application, you would be like, if it's a synchronous function, you would just call it. If it's an asynchronous function, you wrap it under async and then you do await. And then, but in the case of generator, if it's synchronous, you just yield. In the case of asynchronous, effect tries to convert the synchronous way that we write call promises, or in this case, call effects, into one approach.
Does the effect library detect if a promise is returned and then automatically await it? Or does it do some other magic to
No, you need to manually map it, the promises to effect. But it does support asynchronous one if that's what you are worried. So you don't really need to use the, I think the async generator one is useful when you're, when the function that you're calling is an asynchronous one, but effect by nature is asynchronous.
Okay, so I was just wondering, in your database query example, that's inherently going to be async.
Yeah.
But you were just yielding straight away.
Yeah, I know it looks a bit weird, but that's async. So yeah, they just use the synchronous generator approach to model synchronous as well as asynchronous one. So I don't know how many times you've noticed, like you write some function, some simple algorithms thinking like, it doesn't need asynchronous, so it's just like equals to whatever value, and then later on you might need logging or something, and shit, I might actually have to add promise, and then you need to do await everywhere. Effect models the synchronous and asynchronous approach into one yield approach. So everything's, whether it's synchronous or asynchronous, it's able to, they don't really use the async generator. It's really cool feature. If I wasn't using promises, I've used it. Sorry, if I wasn't using effect, I would use the async generator, but they don't really need it. The sync generator one does the job.
Yeah, another one.
Hey, thanks for the talk. This is an interesting question about when you're doing generator functions. I remember crossing paths with something like this in the past, and it seemed like the level of TypeScript support for typing in generator functions was a pain point.
Yeah.
So is that something that you run into with this library, and what's your experience? I don't know if it's the same thing.
Like, I think I said at the start that what effect does to TypeScript is next level type wizardry. So effect has this learning curve that I think like it's gonna like 1 to 2 weeks of like full on pain, you know, like why the hell? Like remember like when we're just doing JavaScript and when we started to do TypeScript at the first time, you will be yelling at your program because it's not compiling. So you do have that learning curve. But what you said about generators being more powerful, no, I do remember that. Everything's a generator, but they have done a really, really good job. The thing about them is like, they've taken some trade-offs. Like, for example, promises has a flat map. When you do promise.then, effect doesn't do that. You have to manually do flat map. So they did that to simplify the type safety. And but anyways, to answer the question, there is a learning curve. There's no pain point of the async generator. I know that pain point. I've done that when I'm doing async, that like you need to use an async iterable, and then you've got 3 parameters. As far as I remember, it's either the first and the second. Yeah, I remember the pain point. But like there's a learning curve. But after that, once you get past through it, it's actually really, really easy. I hope that answers the question.
Yeah, I think so.
You sort of have to try it, but yeah.
All right, anybody else? Nope. Okay. Oh, yeah.
Mind. So in your slides, first, thanks for the talk. In your slides, I seen a lot of similarity, at least like in syntax sugar to RxJS, and some of the features looks like very similar. Is that the case? Is it like an alternative for RxJS, or is it completely different thing?
That's a really good question. I heard a podcast from the author of this guy, Michael Arnoldi, when someone asked him the exact same question. I wouldn't be able to answer it if I don't know that podcast. But basically what he said was like, the problems with observables, RxJS, is that they try to like say that everything is a stream of values, and not everything is a stream of values. It can just be a one-shot value, right? I do Angular in my in my company in the front end, and Angular uses observable a lot. And the problem's like, because it's a stream of values, even though I'm only going to be calling that API call once, I'm going to have to unsubscribe to it because it could be a stream of values. The observable could just be subscribed twice, like subscription one, but the subscription could be called twice, right? So they also have a stream data type to represent a stream of values. So if it's a one shot, it's an effect. If it's a stream of values, then they've got a stream data type. But to answer the question, there are some similarities, especially the retry thing that you saw in there. There are some similarities, but effect is, I would say, supposed to supersede RxJS. I would say it's a better alternative to the complex, like, because it's just a yield star when it's just a one-shot value. It's much simpler than observable when it's just one values. But when it's a stream of values, it's kind of the same. Yeah, no, I like, I see the pain, the resemblance. A lot of people do ask that question. So yeah.
All right. I think we're all good then. Thank you so much.